When compiling a smart contract, there are two outputs that a developer should be familiar with. One is ABI, the second is bytecode. In this video, we're going to be talking about the benefits of understanding ABI as well as bytecode, also the problems that it might solve, as well as how important it is for you as a smart contract developer to understand these concepts. So guys, if you're new to this channel, my name is Dro, and I'm here to facilitate your journey on becoming a blockchain developer. So if you could please hit that like button as well as that subscribe button, also ring that push notification bell so you get all my content as soon as it comes out. And be sure to leave some comments after the video. Now let's jump into talking about ABIs. So the Ethereum application binary interface defines the methods and structures used to interact with a binary contract. Now, when an external application or another smart contract wants to interact with the blockchain, it needs to have some sort of knowledge of the smart contract's interface, such as a way to identify a method and its parameters. Now, this is facilitated by the Ethereum application binary interface. It's similar to the application program interface, or better known as API, which is essentially a representation of the code's interface in human readable form, or a high-level language. Now, in the EVM, the compiled code being stored as binary data and the human readable interfaces disappear, and smart contract interactions have to be translated into a binary format that can be interpreted by the EVM. Now, the ABI indicates to the caller the needed information, such as function signatures or variable declarations, to encode so that it is understood by the virtual machine to call the bytecode. This process is called ABI encoding. Now, Web3 is a bridge between programming languages such as JavaScript, Python, or Rust, and the ABI basically tells Web3 how to interact with the smart contract. Bytecode is the translation of your smart contract interactions into a binary format that can be interpreted by the EVM. This bytecode is composed of two different parts: creation as well as runtime code. Now, when you deploy a contract, the creation code is executed and the runtime code is stored onto the Ethereum network. All right, so if you look at this diagram that I have up here, it shows the process of deploying the smart contract in very simple terms. So on the left, you could see writing contracts to Ethereum. Now, we start off with a front-end IDE like Remix, and we just start off with our very simple code. It could just be one or two functions, doesn't need to be anything crazy. And then you have your Solidity code source, then compiled. Now, this code source is then compiled to the Ethereum virtual machine, and then it is converted into bytecode and then deployed to the Ropsten network via bits and bytes. Now, if you look at the right-hand side, reading contracts from Ethereum essentially requires almost the same process, but in reverse. So you have your smart contract that was converted into bits and bytes. It is then processed through the ABI and retrieved through Web3, which eventually pops out at your web app or your console as a legible smart contract code. All right, so let's look at an example. Now, let's start off by creating a contract called ABI. We're going to create two very simple functions. One will allow us to encode some data into bytes, and the other will allow us to decode the bytes into data. The first function will be called cipher, and the parameters will consist of the following data types: address, which will be referred to as addy, and unsigned integer, which will be referred to as y. This function will be declared external, pure, and will return some bytes that we will store to memory. This function will then return the parameters in an encoded fashion. So we will write return ABI dot encode parentheses addy comma y. Next, we will construct the other function and call it decipher. This function will convert our bytes back into data. The parameters of this function will be bytes and will be returned to data. This function will be declared external as well as pure, and will return our data values, which are addy and y. Now we will decode the bytes by setting our parameters addy and y equal to ABI dot decode parentheses data comma parentheses address comma unsigned integer, and then close it all out. So from here, let's go ahead and deploy our smart contract. Now, as you can see, we have both functions ready to be called. So let's first input some data to be encoded. I will use the default address that Remix has given me. I will then input a random integer for y. Once we call this function, we will get some bytecode like the one we see here. So let's copy that bytecode and insert it into the decipher function to decode for us. Now, as you can see, Remix has successfully deciphered our bytes into tangible data that we can now use. Alright guys, so there you have it. Now, this was a very simple example on how you can use Solidity's ABI bytecode to encode as well as decode information. Now, I hope that you found this tutorial to be useful. If you can appreciate this content, be sure to hit that like button as well as that subscribe button and leave any comments or questions that you may have in the comment section below. I'll catch you in the next video.